Okay guys, our quiz is tomorrow and I gave everyone a study guide, so hopefully we're using this to help us prepare for the quiz for our quiz on ratios. So I just want to look at some of the problems you're expected to see. We are going to see a lot of questions on rates. In general, I want to see that you can actually find a rate in a problem. So for example, in the first one, if it's telling me 8 mangoes for $10, can I identify that as a rate, a relationship between the number of mangoes and the cost that stays constant. So I'll expect us to be able to find rate, to simplify rate, and also to express rate. And this can be in fractions, words, or it could be with a colon as well. And just expect seeing it in different types of word problems. We'll also look at describing ratios, and sometimes that'll mean possibly using a bar model to understand if we have a part to part or a part to whole as we're reading a problem. We've talked a lot about ratio tables this week and how we can use one defined rate to figure out everything else. And the way I know this is a defined rate is because I have a relationship between the miles driven and the gas. In the other ones, I only have one number, so I don't have a ratio because I only have one actual number I'm dealing with, one unit. And with ratios, I need two different quantities that I'm comparing. We'll talk a little bit about solving ratio problems using a proportion and solving for x. And we know the two steps to that, cross, multiply, and divide. But if your setup is not right, you get wrong answers. So we're going to talk a lot about modeling problems and making sure our units are seen so that we know we're solving the correct problem. And then just solving for x. So that's going to be our goal today. Some of the problems we're actually doing today are going to be on the quiz, so it'll be really interesting to see how many of us will use this to practice. Okay, so now I'm just going to model through, and for all of these I'm going to try and code when I can, and by coding I'm just identifying important information and using that to really label my math work correctly. Okay, so let's start off since we have 15 questions to go through. Okay. At the 6th grade school dance, there are 132 boys, 89 girls, and 14 adults. My first question, what is the ratio of boys to girls? So because I want this ratio of boys to girls, I'm going to start labeling that way. And I know I have 132 boys, so they're lined up, and 89 girls. There's no way for me to simplify this because 89 doesn't have any factors that match with 132 except one. So this is already in simplest form. Can I write the same ratio using another form? So I used a fraction, so I could say 132 boys, colon, which I can say in words too, 89 girls. Or I can say 132 boys to 89 girls. Or I could even say for every, but most people just use 2. Can I write the ratio of boys to adults? Okay. Boys, adults. I don't have to write the whole word. And I have 132 boys and I have 14 adults. Just by looking at it, I know these are 2 even numbers, so I know I can simplify them both by the number 2. So I'm going to get 7. And 2 goes into 13 6 times. 12 divided by 2, another 6. There are no other common factors between 66 and 7, so I know this is already in simplest form. And can I write the ratio in another way? Yes. I can say 66 boys to 7 adults. Perfect. Okay, so let's look at the next problem. In a cafeteria, there are 100 milk crates put out for breakfast, and at the end 27 remained. So I'm going to choose to kind of think about this as a bar model. So they started out all together with 100 as my total. At the end they had 27 left. That means they probably drank 73. I can use that because now I can see the 2 parts and the total I can see here. So what is the ratio of milk carts taken to total? So what they took out of the total. Using my model, I can see there were 100 altogether, and they took 73. And this is also in simplest form already, since 73 is prime. What is the ratio of remaining cartons to taken? So I know remaining is the same thing as saying the ones that got left. So remained, that's how much they had left to take in. So 27 were left, and they took 73. And this is also in simplest form. But you see how my actual bar model really helped me there, because I knew the 100 and the 27, so I just had to figure out this other number, the 73, using subtraction. So that's why I really love using bar models. I can see the part to part, and I could also see the total. Okay, let's move to the next set. Multiple choice, which we know we're going to see on the state test, so we'll get used to them. A grocery store sign indicates that bananas are 6 for $1.50. That's one rate for bananas. And the sign for oranges says they are 5 for $3. It's another rate. Find the total cost of buying 2 bananas and 2 oranges. Okay, so let's set this up for bananas first. Bananas and money. 6 for $1.50. I want to know how much 2 of them cost. I can cross multiply, and I'll get 3. 3 is equal to 6x. I like putting the x on the side because when I turn it into a division problem, and now I'm dividing by 6, 3 divided by 6 is equal to x, and I get 50 cents. So this is how much 2 bananas cost. If I want 2 of them. I'm going to do the same thing for oranges. Oranges and money, 5 for $3. I want to know how much 2 costs. So that's 6 and 5x. So 6 is equal to 5x. 6 divided by 5 is equal to x. And I get x is equal to, on a calculator it says 1.2, but we're talking about money, $1.20. This is for my oranges. Okay, so 2 oranges cost me $1.20 and 2 bananas cost me 50 cents. So I'm going to add those 2 together to find my total cost of $1.70. Because I know how much 2 costs, I know how much 2 costs, and here's my answer. Notice that anytime I do multiple choice, I don't even look at the choices until I solve my problem, because that's just there as a distractor. Ben's video game is having a sale on Ben's Game World is having a sale on video games. The store is offering a sale pack of 4 video games for $43. There's my rate. 2 things connected, 2 quantity. What is the unit price? And whenever I see the word unit, I'm thinking of the number 1. So I'm going to write my rate, games and money, 4 games, $43.80. I want to know how much 1 game is going to cost. So when I cross multiply, $43.80 for x. $43.80 equals 4x. $43.80 divided by 4 is going to give me x. And when I do my division on a calculator, I get x is equal to $10.95. I'm not going to show you the calculator part, but once I set it up correctly, I know exactly what I'm going to plug in my calculator. Roberto's Electronics is also having a sale on video games. The unit price of any video game in Roberto's Electronics is the same as the unit price of a video game in the sale pack at Ben's Game World. So I know every game costs $10.95. How much would it cost for a customer to purchase 7 games? I can see kids doing this 2 ways. I can see a kid saying 1 game is $10.95 and just multiply by 7, which makes a lot of sense. And you can just get, with your calculator tomorrow, 76.65. Or I could see a kid going, game, money, $10.95 is equal to 7 over x. It's still going to be the same thing when you cross multiply it out. You're still going to end up, wait a minute, yep. You'll still end up when you multiply this way, 306.1, and then I'm going to have to do some division. There's a problem with that though. Oh, excuse me, because it's 1 game. Let me check my multiplication here with my calculator. That doesn't make sense. 1095, 535, 63. Yep. Okay, I found my mistake pretty easily. Sorry, I'd written down the wrong one when I was originally, I was trying a different unit. But I still end up with 7665. So it comes out the same way. Let's do one more before we go to part 2 because we're at 10 minutes already. The ratio of boys to the number of girls is 4 to 5. So boys to girls is 4 to 5. If there are 120 boys, how many students are there all together? Okay, well, I don't really know because I don't know how many girls there are to figure out all together. But I can cross multiply here. And I get 500 and 4x. 500 is equal to 4 and x. So I'm going to do 500 divided by 4 to get my x. And I get x is equal to 150. So I know that there are 150 girls. So if there are 150 girls and 120 boys, I can add those together to get 270 boys and girls, and that matches my work. Notice how if I had just stopped at 150 for the girls, there was a choice for that. So I had to go back to the problem because this only tells me the number of girls. It doesn't tell me altogether. All right, get ready for part 2 when I go through problems 7 through 15.